Hey guys, today we'll be talking about significant figures. So significant figures are a very, very important concept within all of chemistry. Pretty much every single test you have throughout the year is going to include significant figures in some way, shape, or form. It's easy point solve, so this concept is very, very important. Do a lot of practice problems for this, get used to the concept, and make sure that you always use significant figures in any problems, tests, or quizzes. So first off, what are significant figures? So pretty much significant figures are the idea that numbers are just infinitely big, right? So if we're talking about pi, for example, instead of saying 3.14159 and so on and so forth, we say 3.14. So 3.14 just gives us the idea of how big the actual number is. Or for this example, let's say we're talking about a mass of some sort of metal. 6.000000001 grams or 6.0 grams. They're the same number pretty much. One's slightly bigger, but this still gives us the idea. Significant figures are pretty much just giving us the idea of how much something actually is in terms of mass, volume, or any sort of number anyway. So it's important whenever we're doing sig figs to remember the way to do it. Now the way that I do sig figs is by saying this. So let's imagine a map of America. No, it's not great, but you get the idea. So this is America, USA, and we know that on the left side, we have the Pacific Ocean. On the right side, we have the Atlantic Ocean. So, in the same way that we're talking about significant figures, this is the way that I remember it. So if we're on the Pacific side, so if we're looking from the left, the decimal must be present. So we have P for present and P for Pacific. And then Atlantic, if we're looking at the Atlantic side, we're going to be saying the decimal is absent. So all this is saying, does our number have a decimal or does it not? So in this case, we do have a decimal, and so do we here. Whereas if we're looking at a number like 12, there is no decimal, so we're going to start on the right side. If we have a number like 3.2, there is a decimal, so we start on the left side. So always remember the US map, use the Pacific and Atlantic Ocean. I know it's a bit dumb, but it does work and it's helped me throughout my chemistry career. So let's take a look at these numbers again. So whenever we're talking about significant figures, it's important to remember that if there's any zeros before any number, to not include them. So let's say we're talking about this number again. We added 2 zeros in front of it. So now it's 006.000000001 grams. So if we're looking at this number, are we on the Pacific side or the Atlantic side? Is the decimal present or is it absent? So I see a decimal right here. So we know that the decimal is present. So we're going to start from the left side of the number moving to the right. So just as I said before, it's important to remember not to count any zeros before our first actual number. So starting here, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 significant figures. So here, doing the same thing, is a decimal present or is it absent? We see the decimal is present because it's right there. So we can count from the left side with our first whole number because there are no zeros in front of it. 1, 2 significant figures. Now let's move over here. 12. Do we have a decimal in 12? No, there's no decimal. I mean, you can assume there's one after, but just don't worry about that. Just we know that 12 has no decimal in it, so we're always going to move to the right. So now we look at our 12 and we see that there's an absent decimal, so we're going to start from the right side. So 1, 2, and we know that we have 2 significant figures in 12. And then 3.2. Let's say we're talking about 3.2 here. Is decimal present or absent? The decimal is right there. So moving from the left to the right, 3.2 has 1, 2 significant figures. Now let's do a bit of a harder one. Let's say we have 1,200,000. Do you see a decimal here? Is it present or is it absent? So the decimal is not here. We don't see a decimal in the problem or in the number, so we assume we're going from the right to the left. But also keep in mind that we cannot count any of these zeros. So all of these zeros here are insignificant. So we actually only have 2 significant figures in this number. Now let's say we have a number like this. Do we have a decimal? Yes or no? Is it present or is it absent? So there is no decimal here, so we're going to go again, cancel out all these zeros, and we're left with 1 significant figure. In the same way, if we're talking about with a decimal, let's say we have this number. Right here. Is the decimal present or is it absent? The decimal is present, it's right there. So we're going to move from the left to the right. So we can say that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 significant figures. So whenever you're doing sig figs, it's going to be very important to keep this all in mind because they will take off if you do this incorrectly. So if we're talking about on a problem, it's easy points, how many significant figures does a number have, and you're going to be expected to know is decimal present or is absent, and if it's present, you're going to the right side. If it's absent, you're going to the left side. So as we stated before, with all these examples, we know that if we don't have a decimal in the number, we're going to go from right to left, excluding all zeros before any whole numbers. And if we have a decimal in the number, we're going to go left to right, excluding all zeros before any whole number, just like this one right here. Now let's dive into a bit more into sig figs. So whenever we have sig figs, there's 2 types of rules that we can follow. We can either follow the addition and subtraction rules, or we can follow the multiplication and division rules. So if we're talking about addition and subtraction, we're only going by the fewest decimal places. Whereas if we're talking about multiplication and division, it's the fewest significant figures. So let's say we're adding up 1.0 plus 2.56. So if we do this math in our head, we know that 1.0 plus 2.56 equals 3.56. But this would actually be incorrect in terms of sig figs. So if we're looking at our fewest decimal places, we know that 1.0, if we're looking at the numbers after the decimal, has 1 significant figure, whereas 2.56 has 2 significant figures after the decimal. So our answer would actually be 3.6 because we take the 1 from this side and bring it over here. And then if we're looking at multiplication versus division, we're going to do the same problem. 1.0 times 2.56, and 1 times 2.56 is 2.56 again. But again, this is wrong. So we know that we're going for the fewest amount of sig figs here. So we're going again, is the decimal present or is it absent? The decimal in this case, in both cases, are present. So we have 1, 2 sig figs for 1.0. And for 2.56, we have 1, 2, 3 sig figs for 2.56. So the fewest amount of sig figs in this case will be 2. So our 1.02 sig figs gets the hierarchy in this case, and we're going to do 2.6 as our answer. So as you can see, there are different cases where sig figs do play different roles, and sometimes you're going to be required to do a bit of both. So maybe let's say we have this type of problem. So let's say our problem is going to be something like this. 10.0 plus 2 times 3.79. Okay? So an important thing to remember is PEMDAS. So I'm sure you've learned about this in your algebra classes, but PEMDAS is the important way to work with problems like this. So parentheses, exponents, multiplication, division, left to right, and addition and subtraction, left to right. So if we're following PEMDAS, we don't really have anything to do inside of parentheses, so we can cancel that out. We don't have any exponents, so we can cancel that out. Now we have multiplication, division. We do have multiplication right here. So it's important to follow those sig fig rules. So if we're doing the significant figures of 2 and 3.79, because multiplication is the fewest amount of sig figures, we know that 2 does not have a decimal, so it's absent. So we move from the right to the left of 2, we know that it has one significant figure. And if we're looking at 3.79, there is a decimal, so we move from left to right, and we know that 1, 2, 3 significant figures. So now, looking at our fewest amount of sig figs for our multiplication division side, we take our calculator, and we're going to get 2 times 3.79, which gives us 7.58. So, bringing down our 1.0, we're going to add that to this answer, which is 7.58, but we need to keep in mind the fewest sig figs, which is 1. So 7.58 actually rounds to 1.00 plus 8, because 1 sig fig is all we need. And then now we take a look at our 1.0 plus 8, and we see which one has the fewest decimal places. This one has 2 decimal places. This one has 0. So we can assume that 0 decimal places is fewer than 2. So 8 plus 1 is 9. 9 is your answer. So it's important whenever you're working out these problems to follow the principles of PEMDAS and also to follow the significant figure rules that we talked about. So remember, going back to the very beginning of this video, if we're talking about having a decimal present, you're moving from left to right. If you're absent, you're moving from right to left. If we're talking about addition and subtraction, it's going to be the fewest amount of decimal places in a number. And then talking about multiplication and division, it's going to be the fewest amount of sig figs in the number. All right, so now I have a few practice problems for you guys. I encourage you to bring out a paper and pen, just kind of work these problems on your own. It is important to kind of, like I said before, to reinforce the concepts you learned in class in these videos, because chemistry is practice, practice, practice. So let's hop into this. How many significant figures? This is like a simple test question that you are pretty much 100% going to be asked at some point in the year. How many significant figures do these numbers have? So, looking at these numbers, we know that these all pretty much look the exact same, but they're all going to be different. So, going back to what we talked about before, is our decimal present or is it absent? So in this case, we see that we do have a decimal right here. So from present to absent is from left to right, like the Pacific and Atlantic Ocean. So we're going from left to right. So we know that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 12 significant figures. Now looking at number 2, do we have a decimal? There is no decimal here, so we start from the right going to the left. And we have to remember that all of the zeros before the first whole number, which is 1, are non-valid. So we don't have to worry about any of these zeros right there. That's our only significant figure. Let's take a look at number 3. Do we have a decimal? No, so we go from right to left. Do we have any zeros before our 1? No. So all of these are significant. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 significant figures. Now lastly, we're looking at this one. Is there a decimal? Yes, there is. It's right there. So again, we're going from left to right. So we start off looking before our first whole number, how many zeros are there? And those all go away. We only have one significant figure. So it's important whenever you're looking at these numbers, because they all do look very similar. They all do seem like they'd be the same thing, but as you can see, they're very different just based on if there's a decimal or not and how many zeros actually are before the first whole number. So moving on to answering some questions with sig figs. We're gonna have some addition, multiplication, subtraction, division. So starting off with our addition. As you remember, the addition rules state that whenever you're adding or subtracting a number with respect to sig figs, the number with the least amount of decimal places after the decimal takes the higher point. So we're looking at these two numbers, and it's an addition problem. So we say this has 1 decimal place, this has 1, 2, 3, 4, 5, 6. 1 is less than 6, so this one takes the higher point. And we know that if we pull out our calculator, 1.0 plus 2.637589 gives us 3.637589. So if we're talking about this, we know that we're gonna have 3.6 as our answer with respect to sig figs because of that singular decimal place after the decimal. Moving on to this one, 1.0 times 2. So we know that according to the multiplication division rules, whenever we're talking about multiplying or dividing a number with respect to sig figs, is which number has the least amount of sig figs. So looking at this one, is the decimal present or absent? So we see the decimal right there in between the 1 and 0, so it's present, so we're moving from left to right, so that's 2 significant figures. And here, looking at our 2, is there a decimal? There is not, so we just assume going from right to left, we see 1 significant figure, and we know that 1 is less than 2, so we will have 1 significant figure in our answer. So 1.0 times 2 is 2, so our answer would just be 2. Now moving down below, we see 4.6379 minus 2.6378. So again, with the addition and subtraction rule, it's whichever one has the least amount of decimal places. So in this case, we actually have 1, 2, 3, 4 right here. In this case, we have 1, 2, 3, 4 right here. So they're actually the same. So our answer is going to have 4 decimal places. So if we subtract 4.6379 minus 2.6378, we get 2.0001. So that would be our answer, 2.0001. And we know that because this has 4 decimal places after the decimal, just like these two had 4. And then finally, 9.6 divided by 1. Now I know that you may be tempted to just throw 9.6 right there, but it's actually incorrect. So we know that our multiplication division rules state that the least amount of sig figs is the amount our answer will have. So if we're looking at this amount of sig figs in the top, is there a decimal, yes or no? So we do see a decimal right here, so it's present. So we move from left to right, so we see 2 sig figs on top. Now looking at our bottom number, is there a decimal? No, there's not. So we see 1 significant figure. 1 is less than 2, so 1 takes the higher point. And we know that 9.6 divided by 1 is 9.6, but because we're only talking about 1 sig fig, our answer is actually going to be 10, because again, there is no decimal here, so we're moving from right to left. We can cancel out this 0 because it's before the first whole number, so we only have 1 significant figure in our answer of 10. So it's important, whenever you're doing these sig fig calculations, to keep in mind the rules, because it does sometimes seem tempting to throw in 9.6 there, or just to throw in and round this number down to 2, or sometimes maybe to make this 2.0. Just always keep in mind your significant figure rules, don't get them confused, and again, practice, practice, practice. I'll have a few questions in the study guide down below for this, and I hope that helps you. Thank you for watching.